down and has to return back to the US this evening. He's come to us from Cornell University in New York, Dr. Lisa Newman, who wants to talk to us about genetics of breast cancer. Please, it's not the same topic, but she has to leave very early. Just like a woman. I couldn't talk for her, so she has to talk for herself. Dr. Newman, please.
Well, thank you. It is such an absolute tremendous honor. Is this on? Can you guys hear me? It's a tremendous honor to join you. When I found out about this meeting and saw that there was a small window of an opportunity to be with you here today, even for one day, I absolutely jumped at the chance. It's an absolute pleasure to be here. My very first visit to Africa was actually to Dakar, so it's bringing me full circle. Oh, that's it. Oh, is that right? Okay, thank you. So, I am going to talk to you about the genetics of breast cancer, not genetics, genetics. Sorry about that typo. And in particular, I'll be focusing on the genetics of breast cancer related to African ancestry. And this has been the basis for a lot of the research that I've been doing in collaboration with several colleagues in different areas of Africa over the past 16 years. My interest in this area is based upon my history of doing breast cancer disparities research, looking at the breast cancer burden of African American women compared to white American women, and the characteristics of breast cancer in these two population subsets are shown here. African American women present more with late advanced stage disease compared to whites, and we have higher death rates from breast cancer. And those two features are very heavily influenced by socioeconomic disadvantages that persist in the United States between whites and blacks, with higher poverty rates in black women, worse access to the healthcare system, and so they're more likely to present with advanced stages of disease. However, the other features that are listed on this slide are characteristics that really cannot be ascribed to socioeconomic status, such as the fact that black women are more likely to be diagnosed with breast cancer at younger ages, and about 40% of our black breast cancer patients are younger than the age of 50, compared to only 1/5 of the white breast cancer patients being younger than the age of 50 at diagnosis. The topic of most of my presentation here over the next few minutes will be related to the different biology of breast cancer in black women compared to white women in the United States, with African American women having twice as high risk of the triple negative breast cancers compared to white women, higher rates of the high-grade aneuploid tumors as well. There's also a very poorly understood higher incidence of inflammatory breast cancer, which is a biologically very, very aggressive tumor phenotype. There is a twofold higher incidence of inflammatory breast cancer in black women compared to white women, and there's a twofold higher rate of male breast cancer in the African American community compared to the white American community. And again, all of these latter features we really cannot ascribe to socioeconomic status, so it's definitely incumbent upon us to investigate genetics and inherent tumor biology accounting for these differences. The higher rates of triple-negative breast cancer in black women compared to white women is especially compelling as a research topic and as a cause for the higher mortality rates that we see from breast cancer in blacks compared to whites, because, as you guys are all aware, triple-negative breast cancer indeed is an inherently more aggressive tumor biologically. It's more likely to metastasize compared to the non-triple-negative breast cancers. And for these cancers that lack the estrogen receptor, the progesterone receptor, and the HER2 new marker, we do not have any targeted therapies. So these patients are more likely to require chemotherapy, which of course has more toxicity. Now, in addition to triple-negative breast cancers being more common in black women, we also know that they are a hallmark of hereditary susceptibility for breast cancer. And in particular, families that have BRCA1 mutations, about 90% of the breast cancers that those women carriers of BRCA1 mutations, 90% of those cancers are triple negative. So this then begs the question of whether or not African ancestry in and of itself is associated with hereditary susceptibility for these aggressive tumor phenotypes. And this is what initially prompted my collaborations with colleagues in Africa. We wanted to look at how African ancestry, how African heritage is associated with the genetic risk, genetic predisposition for triple-negative breast cancer. And in addition to this research being very meaningful in terms of understanding disparities and learning how to better treat cancers in women with African ancestry, it also gives us a unique and powerful opportunity to try to figure out the root causes, the pathogenesis of triple-negative disease. So for the longest amount of time, I've been partnering with researchers in Ghana, which of course is located in Western Sub-Saharan Africa, and most of my work has been in partnership with the investigators at the Kamfanochi Teaching Hospital located in Kumasi, Ghana, but we've also had some partnerships with the Korle-Bu Teaching Hospital in Accra as well. And so wonderful to see Dr. Jonat Clegg here. Thank you for your collegiality and partnership over the years. So this summarizes what we have found in the 16 years that we've been working with the Kamfanochi Teaching Hospital in Kumasi. More than half of the breast cancers that we see in Ghanaian women from Kumasi are triple-negative tumors. In the United States, about a quarter of the cancers are triple-negative, and about 15–16% of white American breast cancer patients have triple-negative disease. And of course, we see a much younger age distribution of breast cancer in Ghanaian women. In partnership with the Korle-Bu Teaching Hospital, found pretty much the same thing. The majority of the breast cancers are triple-negative. Now, in the past 5 years, we've also been partnering with investigators in Ethiopia representing East African women, and we weren't sure what we were going to find when we first initiated the Ethiopian partnership because very little had been published on breast cancer in East Africa. And to summarize, these latter bar graphs are the most important components of this slide. We actually found similarly low rates of triple-negative breast cancer in Ethiopian women. In Addis Ababa, 15% of the breast cancers are triple-negative, exactly what you see in white American breast cancer patients and in European women. Again, Ghanaian women had the highest rates of triple-negative disease, more than half, and for African American women, the frequency of triple-negative tumors is intermediate between that of Ghanaian women and white Americans. So we think that this is actually evidence in support of our hypothesis that there is indeed an ancestral genetic explanation for these patterns of breast cancer between these different population subsets. Because if you, and we call this oncologic anthropology, if we look back at the African diaspora and the slave trade from several centuries ago, we see that Western Sub-Saharan Africans, including from contemporary Ghana and Nigeria, were brought across the ocean to serve as slaves in the American colonies several centuries ago. So as African Americans, we have substantial shared ancestry with contemporary Ghanaians and Nigerians, Western Sub-Saharan Africans. But we actually have little shared ancestry with East Africans because the slave trade from East Africa largely went further eastward and brought East Africans over to the Mideast and to Asia. So we think that this explains why the breast cancers of African American women are more similar to the breast cancers that we see in West Africa compared to East Africa. We've done other markers aside from ERPR and HER2/neu. We've been looking at the quadruple negative breast cancers, which are cancers that are triple negative and also negative for androgen receptor. We've also looked at the mammary stem cell marker, ALDH1. And in all of these situations, we see that the tumors of white Americans and Ethiopians are more similar to each other, and the tumors of African Americans and Ghanaians are more similar to each other when you break them down into couplets. Very recently, we recruited this magnificent, brilliant geneticist, Dr. Melissa Davis, to serve as the scientific director for our International Center for the Study of Breast Cancer Subtypes. And Melissa has done most of her research in studying a gene called the Duffy gene, which accounts for the Duffy blood types. And this became very intriguing to us because it provides a genetic explanation for these varying breast cancer patterns that we've been seeing. The particular variant of being Duffy null is almost fixed. It's seen about 100% in Western Sub-Saharan Africans because about 6,000–7,000 years ago, being Duffy null was under very powerful selective evolutionary pressure because it provided resistance to malaria. Now, following the development of malaria being endemic through the mosquitoes in Western Sub-Saharan Africa, the Bantu expansion occurred, and many West Africans populated the different regions of Africa, including East Africa. So there is a heavy West African shared ancestry influence on East Africa, but it's not fixed, and so you do not see this Duffy null genetic variant to the same degree in East Africa that you see in West Africa. There's a very different prevalence of malaria in East Africa because of the mountainous parts of East Africa, and so again you see different patterns of this variant being Duffy null. In the United States, because of genetic admixture, African Americans have a different prevalence of being Duffy null as well because of the mixture with white Americans. And so again, almost all Western Sub-Saharan Africans are Duffy null, 60–90%, depending on the study you read, of African Americans are Duffy null. Very few white Americans and Europeans are Duffy null. And again, you see it in an admixed rate, Duffy null prevalence in East Africa.
Between the West Africans and the Ethiopians. I mean, other than kind of what you looked at with the Duffy gene, you know, it sounds like both are sub-Saharan, but I mean, very different in terms of how the expression of triple negative breast cancer is. Can you kind of talk a little bit about it?